Today I am going to tell you about neutron stars. I told you in the last video also. Hello, so my name is Shlok. Today I am going to tell you about neutron star like I said in the last video. Some things. A supernova is where a neutron star also blasts. Fully blast means it means a full blast happens. Full blast, like very violent supernova. I told you, a plasma is a heated matter. It's when a matter type of matter loses or gains more electrons. It's called a plasma. Heated up means take some matter, catch it and heat it up like a blaze. This is what is called a plasma. Heated plasma. It blasts with. A neutron star is a star full of neutrons. Actually, a star contains of electron, proton, neutron, three of them, and hydrogen and all gases. But this neutron star contains only of neutrons, which neutralizes the number to get equal the protons and electrons in the matter, in the atom. Only neutrons are there and some of electrons and protons. A little only bit of. High mass stars are also become. If a star is high mass star, like more than sun's mass, then only it can become a neutron star. If a high mass star has a mass of 20 times more, less than 20 times the sun's mass, so it will be a neutron star. The collapse can stop, but more than that, a black hole we cannot. Star's core is very hot, big. In neutron star also from neutrons whizzing around, fusing. Neutrons also hate to get squeezed together very hardly, but it happens because the force is more stronger there. Like I told you, when a star has the mass more than 20 times the sun's, less than 20 times the sun's mass, more than 20 times the sun's mass actually, the collapse cannot stop. It's an unstoppable collapse then to become a black hole. A collapse is when the core is shrink and the gravity overpowers the star. Here comes neutron degeneracy, pressure, but it also doesn't work from stopping the collapse. But the pressure is higher. Neutron degeneracy. Pressure of the is pressure is so high there. In the neutrons get squeezed together fully, compressed. Neutrons When a neutron star blasts, it's also called a supernova. It blasts like the pressure is lower. It happens like directly a shock wave is created. It directly freezes, fully freeze is when a neutron star blasts. All the neutrons one together stop whizzing here and there, fusion and all get freezed, directly get freezed, all the neutrons inside, and a shock wave is created. and the star blasts. Think it of like a full filled of uh, air balloon, and from magic the all the air is like a ice or it's gone away. What will happen? The from the magic, if it happens, what will happen? The balloon will blast. So this is how with a star. Same with a star. Actually, same with a star. It blasts and becomes a violent supernova. It's too hot. Neutron star's energy is too much at that time. Energy is about neutron star's energy is many times the Earth's energy. Sun's mass and energy. Sun has a low mass than neutron stars. Mass and energy is lower, but too much of suns also. Newtonium is a gas means made of neutrons, which is in the neutron star. It is the cubic dice of made of newtonium weighs 400 million tons. That's the weight of every single car and truck in the United States. The full weight of that is newtonium cubic dice will become newtonium cubic dice. A neutron star is the gravity of it is 100 billion times the Earth's gravity. 100 billion. 100 billion times. 100 billion times. Think 100 billion times. The Earth's gravity. I also don't know how strong is Earth's gravity. It's like when you jump up high, you will come down in a piece of second. Your melted form also will come in a blast in a one piece of second. This strong is the intense gravity of a neutron star. This is how this is the big intense gravity of a neutron star. Energy also too much. Sun's mass and energy is too much low from. And think of it like a neutron star is like a size of 20 kilometers across. The sun's mass and energy is 300 times 300,000 times the earth's mass and energy. Think of it packed into a city type of sphere which has a size of a city, all packed into that. It's a neutron star type of, and it blasts sun. It blasts all the away and all the way away. The neutron star blasts the all energy away in a supernova, and some of it also loses its energy mass while blasting a supernova. It's called supernova. Is really violent and violent and violent. When it blasts, it's one of the most dangerous things that one of the most violent things that universe can offer to us. Very violent, but to hurt us it needs to be at least 100 light years away from us, and nothing can hurt us now. Actually, no star can do that now to us. We are full safe. Breathe easy. We are full safe. Safe. Actually, no star can hurt us. Like Betelgeuse is a full big, but it's too far away from us in the Orion constellation. Right, I don't know. There is one, but it might explode. It's the low mass end of the scale. I don't remember the name, but it's too far. It's 100 light years, but it might explode actually. But it will be there, but there is no. And sun, our sun also can't be a supernova because it's also a low mass star, not like Betelgeuse Sirius star. The magnetic field of a neutron star is also so much intense. Like think of it like you're keeping uh, a magnet circle trillion kilometers away from it, and if you just leave it a little, like at the end of a supernova, it will directly reach till it. This is how intense how supernovas are. No, a neutron star. Neutron star also has one more name. It's called a pulsar. Pulsar, which is too hot also. Neutron stars magnetic too much and gravity also so much. Heat you don't imagine. It's heated up. Heated. And when a spinning object is squeezed, it has a more spin. It gets more spin actually. And this same happens with a neutron star. Think of it like a ice skater drawing in his arms. Like ice skating like this. And the spin will increase. This is what happens with a neutron star. It spins and gets squeezed also. It gets squeezed fully squeezed and heated up. But sometimes because of the intense magnetic field, the magnetic field acts like a speed brakes of a car to slow it down, and then it loses mass. It stops the neutrons and the supernova blasts. The supernova blasts because of this. The magnetic field holds it like a brakes actually, and the magnetic field is also created by the spin only. So the spin stops and the magnetic field weakens. Actually, this happens because of that weakening. There was the spin type is so fast, and when it breaks up like a car's brake, when the magnetic field acts, it like stops the spin and becomes a supernova blast. Supernova blast. Because of the spin, it can create more magnetic field. Ha 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 ha. It's like pulling the magnet away from us. Like the intense gravity is like if you are holding a big magnet and you are a well trillion kilometers away from the super no the neutron star, still the magnet will be uh, go till there, reach till there with you with the magnet, because the magnetic plus gravitational force is too much there. It's 100 billion times the Earth's gravity and trillion times, a trillion times the sun's magnetic field, and Earth's magnetic field quinti quintillion times. Don't think of it like too much. The gravity is going through. There was one star called LGM1. Little green was one was found. It was a binary star. Some neutron stars are like a neutron star and with a ray of heat, a normal star orbiting it. These are called binary neutron stars. Binary stars. I will tell you about this also in next videos. Binary stars. Binary stars. They are called. It's a binary star. Do you know what is a magnetar? Magnetar is the most magnetic object of the universe. It's like a neutron star only, magnetars. It has a magnetic field, like it can directly blast away and directly use brakes to a neutron star spinning. Direct, and the star blast with a supernova. And then the neutron star is one of the neutron stars. One of the name is magnetars. It has a well over a magnetic field quadrillion times the sun's magnetic field, and it's well over subquillion octillion times the Earth's magnetic field. Octillion times, actually. It's the octillion time. This is called a magnetar. It's really massive, and when a small earthquake happens on Earth, it's also very strong to move a little of mountains, to destroy the buildings. But if a magnetar starquake happens, it a centimeter block is if a centimeter is cracked, the or like the half the way the star will be gone in a blast. It's really hard to imagine the mag when a sun puts out a flare, a tantrum means I know a fire ray rays, so it's called a solar flare. It's well over many nuclear bombs, 100 millions, billions of nuclear bombs. It's well over. It's well over 100 million times or billion times. solar flare we call actually, but a magnetar flare you can't imagine. Many times it can blast away like a supernova. A magnetar flare is well over trillion quadrillion times the solar flare. It can push away the earth quadrillion light years away if it goes on our earth. Once in 2004, what happened? The release of energy happens. So much of energy is released in a magnetar flare also. So much of amount is blown away. Type of. In 2004, one mind blasting event happened on Earth. Uh, some satellites were around Earth, right? Uh, Nearby, many light years away, object was there, and a blast happened, and a full rays of X-rays came on Earth, and it made changes in the atmosphere of Earth, like compressing the atmosphere, heating it up, and mixing into it, slammed into the Earth's atmosphere. Still, we were safe. The X-ray came in a violent way, like blasting way. X-rays came to Earth here. It was quickly determined to be a neutron star, no, a magnetar. It was a X-ray blast. It was named SGR 180 1806 minus 20, a magnetar. It was too intense of a blast, full. And you think now a surprise. The magnetar distance was 50,000 light years away from us. That's halfway the distance of our Milky Way galaxy. And from this distance, when the rays came, X-rays came, it still hurted us. Now think of it. This all happened. It was 50,000 light years away from us, and the rays came till here on Earth, and changed the atmosphere fully, and crushing the atmosphere also. And it also slammed into the satellite, and it was meant for detecting X-rays and all gases, all the radiations, X-ray radiation. It was meant for making. Like I told you, visible light we can do in the light video 24th I told you. So the satellite which detected it was one of the X-ray satellites. Thank you. We'll meet next time in the next video. Black holes. Bye bye.